Let us consider rate of change of velocity, that is also called acceleration. Take down acceleration. This is also called rate of change of velocity. Rate of change of velocity. See, change of velocity is indicated by v minus u. This is called change of velocity. Velocity. That is, v is equal to final velocity and u is equal to initial velocity. Therefore, v minus u. Rate of change of velocity means the change of velocity divided by time. So this is called rate of change of velocity. So this can be represented by v minus u divided by t. That is equal to a. Okay. So this is called acceleration. Now let us see the unit of a. See, that is a change of v. What is the velocity? What is the unit for v? Velocity. Velocity unit is meter per second. U also, the unit is meter per second. So the difference is v minus u means that is also meter per second. And v minus u divided by t means that is meter per second divided by time is second. So it is ms power minus 2. Do you understand? So what is the unit of acceleration? Unit of acceleration is meter per second square. What is the unit of velocity? That is meter per second. Whether it is final velocity or initial velocity or difference in velocity. In an uniform motion, the acceleration is 0. Why? Because v is equal to u. In uniform motion, acceleration is equal to 0. Why? Because v is equal to u. There is no change in velocity. So v minus u becomes 0. Therefore, a is 0. Do you understand? Now this accelerated motion can be represented by a graph like this. Y-axis, x-axis. And in x-axis, you can mention the time in second. In y-axis, the velocity. So, the change in velocity with respect to time. So, this is the accelerated motion. Are you able to follow? For every change of time, there is a change of velocity. When the acceleration is negative, it is called retardation. It means when v is less than u, in that case v minus u becomes negative. Is it not? Therefore, a becomes negative. Is it not? So this negative acceleration is called retardation. Okay. And the retarded motion can be represented by this graph. So what about this? This is accelerated motion. Accelerated motion. Now, a retardation can be represented by this is x-axis and y-axis, time, velocity. Now it comes down like this. So with the increase of time, the velocity comes down. Therefore, this is called retardation. That is negative acceleration or retarded motion. But it is a uniform acceleration in both the cases. You may ask me, sir, whether there is non-uniform acceleration. Yes, when the velocity changes is not at uniform rate, then it is called non-uniform acceleration. Now let us represent by the graph. Representation of motion by graph, that is graphical representation. Graphical representation of motion. Let us have distance time graph. Distance time graph. Usually in x-axis we take time t in second, and distance is taken in y-axis. It is represented by s. S means distance, and its unit is meter. That is distance. So this is time. Now let us draw the graph. Say this is 0 origin, 20 minutes will take, 40 minutes, 60 minutes, 80 minutes, like that it goes. So this is t. So t is given here in minute. And what about distance traveled? Distance traveled, that is given in kilometer. Okay. Now let me consider a man is traveling at uniform speed like this. In 20 minutes he travels, say, about 20 kilometer, let us mark like this. In 40 minutes it is 40 that is here. So likewise it goes. From the origin you can draw a straight line. Now this is a uniform motion. Why? Because the velocity remains same. Let us mark some place like between 40 and 60. So let me say this is 40, this is 60. Let me call it T1, T2. At that time, what is the distance traveled like this? So this is 60. And what about this? Let me call it, this one is S1 and this is S2. Okay. Now we can determine the speed based on this. So what is speed? The speed is, here you have got T1 and a T2 value. So here this is S2 and S1. Therefore speed is equal to S2 minus S1 divided by T2 minus T1. Are you able to follow? Now we can work out, say, what is S2? 60 kilometer. What is S1? 40 kilometer. What about this? This is 40 and this one that is T2 is 60 and this is also 40. So it means this is 20 by 20, that is equal to 1. It means he has travelled 1 kilometer per minute. Are you able to follow? So this is the speed. Got it? Suppose if you want to convert this into second, how to do that? 1 kilometer, you have to convert into meter per second, that is in SI unit. 1 kilometer is equal to 1000 meter, okay? And 60 second is equal to 1 minute. 1 minute. Therefore, 1 second. So you can replace by 60 minutes here. So 1 kilometer means 1000 meter divided by 60 second. 60. So you can put like this. Now divide it. So this is 3 2s are. This is 50. Is it not? Now what is the value? 16 3s are 48 balance 2. So 16.67 meter per second. So we can mention the speed in 2 units, is it not? So what is the speed? The speed is 1 kilometer per minute or 16.67 meter per second. This can be represented like this or meter per second. And this is the ideal way. Got it? Okay? Right. Now, this is of uniform motion, is it not? So, we have drawn the graphical representation. We have represented the uniform motion in a graphical way. Okay? Right. Now, non-uniform motion. How to represent it by graph? Non-uniform motion. Okay, so this can be represented by, so this is T and this is S. So distance and this is time. x-axis, y-axis. So this is an accelerated non-uniform motion. Okay, so every time the distance is varying, so it can be like this. So such kind of non-linear one is called non-uniform motion. Why? Because it is an accelerated non-uniform motion. Okay. So initially the car starts with a low speed and go to the second gear, third gear, fourth gear. Likewise, you are increasing the speed. So it won't be uniform, okay, because you are increasing the speed. Now let us study the velocity time graph. Velocity time graph. Here, let us consider the x-axis, y-axis. In x-axis, as usual, you can put time, but in hour. And what about velocity? Velocity is given in kilometer per hour. Now, let us consider 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, like that. And similarly, you have 10 kilometer, 20 kilometer, 30 kilometer, 40 kilometer, 50 kilometer. Okay? Right. Now, an object moves with uniform velocity. An object moves with uniform velocity. Means, for example, this is 10, 20, 30, 40, 50 kilometer per hour. It starts from 0 time, but its starting speed itself is 50 kilometer. So, at 1 hour, okay, at 1 hour, it has started at A. So it goes on at 50 kilometer, constant speed, and it reaches B. So let me say this is T1. In T2, this is 1, 2, 3, 4, 5. So this is T2. In T2 time, it reaches here. The same velocity is there. There is no change in that. Now, this is A, B, C, and this is D. Now, what you can do is, you can draw, that is AD and BC here. Okay, and this is the rectangle you are able to get. What about this? This is AB. What about this? This is AD. And this one is CD. Right? Now, the distance moved by the car is equal to the area of the rectangle obtained in this graph. Just by measuring the area of the rectangle, you can get the distance moved by the car. How? Take down distance moved by the car is equal to AB into AD. AB into AD, or AD into CD, either way you can say. Okay. So what about AB? AB means AB. This is 50 kilometer per hour. So you can put 50 kilometer per hour into what is CD? CD is the difference between this 4 and this is 1. So it means 3 is the distance. Okay. So into 3. Now what is the distance traveled? 150 kilometer, and this is hour, is it not? So kilometer per hour into hour, cancel. So the distance traveled is 150 kilometer. So from this it's clear that the distance can be obtained by calculating the area of the rectangle obtained in the graph. Okay, so that is the distance checked out. So distance is nothing but the area of the rectangle in the velocity time graph. Okay, you can mention that one also. So what is distance? Distance is equal to area of rectangle obtained in the graph in velocity time graph. Are you able to follow? So this is the formula to be used, okay, based on the graphical representation. Got it? Now let us discuss the velocity time graph. Velocity time graph for uniform acceleration. Okay, take down velocity time graph for uniform acceleration. Uniform acceleration. Okay. Now let us draw the graph. So x-axis and y-axis. X-axis, y-axis. What is x-axis? Time. What is the y-axis? Velocity. So it is given in second. This is given in kilometer per hour. Okay. If you want, you can maintain as hour also. Okay. Now, let me say that is here you have time in second, 5 second, 10 second, 15 second, 20 second, 25 second, 30 second. Okay, and let us measure the kilometer here. 10 meter, 20, 30, 40, 50, 60, 70. Okay. Let us consider it has a uniform velocity like this. Now let us take the T1 at 10. T2 at 20, 15, 20. This is T2. So draw a line and that meets here. Similarly, meets here. So all these things should be drawn in a decent graph. So this one this one. Okay. Now this is 10, 20, 30, 40. So this is 40 hours per minute, per 40 kilometer per hour, and this is 30. Okay. And what about this 10 and 20? So this is the graph. And you can have like this. So this is the point A, and this point is B, and this is C, this is D, and this point is E. Okay. Now what about the area A, B, C, D, E, A? Okay. That gives the magnitude of the velocity. Take down. So velocity is given by area of the figure A, B, C, D, E, and again A. So A, B, C, D, you can close it. I will highlight this with the red ink. So A, B, B, C, D, E, okay, and you can close. Are you able to follow? So this is the area of the triangle, not triangle, one square and one triangle. Okay. So you can include A also. A, B, C, D, E, A. Okay. So this area represents what? The velocity. Are you able to follow? So can you calculate the velocity here? See, AB. Now you have got a triangle here and a rectangle. Okay. So what you are supposed to do? Velocity is equal to area of A, B, C, D, is it not? Plus area of triangle ADE. Okay. Now what is the area of ABCD? ABCD is a rectangle. Okay. So what is this? Length into breadth, is it not? So 20 minus 10 is 10, is it not? So 10 into, you can multiply like this, BC into CD, plus what about area of triangle? Half into, what is the base? AD. What is the height? ED. Therefore BC is 20 minus 10, 10 into CD. CD is 0 to 30. So 30. Okay. Plus, what about this half into, what is AD? AD is how much? The same, 20. Is it not? AD is 10. Into, and actually this 10 is what? That is in second. Remember, 10 second. And what about this 30? That is given in kilometer per hour, is it not? Okay, so that is kilometer per hour. And similarly 10 second, okay, into height is 10, is it not? 30 minus 10, 40 minus 30, 10 again. Okay. So 10 kilometer per hour. But all should be in same unit. So you have to convert this. The 10 seconds should be converted into what? Hour. How many seconds is equal to 1 hour? 3600 seconds. Therefore 10 divided by 3600 seconds. So it means we have converted into hour into 30. So this gives you in kilometer. Plus what about this? Tell me. Half into 10. Again 10 by 3600. Okay. Into, and what about this? Kilometer per hour. Okay. So 10 kilometer per hour. So the result is obtained in kilometer per hour. Okay. Right. So you can cancel this 0 0 0 0, and this is 12, and this one also cancelled. Okay. And this is 1 by 2 into 36. Right. So 1 by 12 is equal to 1 by 12 plus, what about this one? 1 by 72, because 2 into 36. So 1 by 72. Okay. Now what is the LCM? 72. So here how many times? 6 times. This one 1. So 7 by 72. So 7 by 72 kilometer per hour is the what? The velocity. So likewise you can declare. If you want to convert this into meter per second, you can convert 7000 meter divided by 1 hour, 72. This is, it is given in 72. So what you are supposed to do, you have to convert this into second. So 72 into how much? 3600. Okay. Now you can cancel this and you can proceed with that. Okay. So 70 divided by 72 into 36. So 72 into 36 is equal to 2592. So 70 by 2592. So 70 divided by 2592 is equal to 0.03 meter per second. So this is the velocity. So this is the way you have to work out. And for this one, 7 by 12, 72. So that gives 0.1. So 0.1 kilometer per hour. So if you want to give this in kilometer per hour, you can have this. If you want to give the velocity in meter per second, you can convert like this. Okay. And non-uniform acceleration can be represented by this diagram. Okay. So non-uniform acceleration. So let us represent this by a graph. So it starts from 0. Let us put 4, 8 second, 12 second, and 16 second like this, and 10 kilometer, 20, 30 like that. So this is the meter per second. Let us have it in meter per second. So this is the velocity. So in that case, probably it may go up like this, and there is a change in velocity, and it goes like this, change in velocity. That's all. So this is called non-uniform accelerated motion. Okay.